What's up, guys? Welcome to lesson 3-1, fractions and decimals. All right, let's do it. So here we have, first this question number 26 is all about converting a fraction to a decimal. The most important thing to remember with these problems is that a division bar is nothing, or a fraction bar is nothing more than a division symbol. Fractions are really just division problems suspended, so they're not being carried out. It's also representing a part out of a whole and all that you've always learned. But if we want to convert it to a decimal, we just carry out the division problem. So I'm going to go ahead and set it up here. We don't have a ton of room, so I'm going to try it just like this. We're going to say it's always the numerator divided by the denominator, so 5 divided by 11. We don't have to worry about the negative symbol. We just remember that we have to apply it at the end. Our answer is going to be negative. Other than that, right now we don't need it. So does 11 go into 5? No, it doesn't. So when that happens, and it shouldn't, right, if we're having a true fraction. So what we got to do now is we got to remember that every integer actually has decimals that go on into infinity, zeros that go on. 5 is really 5.00000. Now all we got to do is then treat this just like it's 11 divided by 50 and carry out the problem. So we say 11 goes into 50 how many times, and that is 4. Doing my best here with the space I've got allotted. But remember, we need a decimal up here too. We don't just put a decimal down there, we got to bring it up top. And the decimals always line up in a division problem. Now what's 4 times 11? That is 44. We do a little subtraction, we get 6. Now what do we do next? Okay, we need to bring down a number. Well, guess what? We got an infinite supply of zeros. Bring that down. 11 goes into 65 times. What's 5 times 11? That is 55. Oops. And we do another subtraction. We've got 5 now. Let's bring down another 0. We got a 0 here. 11 goes into 50 how many times? That's the same as this first problem. So we can once again say 4. 44. And guess what? Do you see a pattern emerging? Now we're going to get a 6, and it's going to repeat like this. 4, 5, 4, 5, so on and so forth. So guess what? If we're going to write this as a decimal, it's simply 0.45. Negative, we got to remember that negative symbol, and then we have to apply a bar. What does a bar mean? A bar means that this fraction will this decimal will continue on indefinitely into infinity in a repetitive pattern that says 4, 5, 4, 5. So the bar goes over whatever 2 numbers or 3 numbers or 1 number, whatever it may be, is repeating on infinitely. So there's how we solve number 26. Now let's look at 36. We're trying to figure out which value is larger, or are they equal? Well, we've got 5/9 over here. For those of you who are unfamiliar with 0.6 repeating, this is actually the same as 2/3. All right, that's what 2/3 is. 2/3 is actually repeating 0.66666 on into infinity. So which one's bigger? Well, now if we want to do a proper comparison between two fractions, we need a common denominator. And guess what? 3 goes into 9. So our common denominator can be 9. Well, how do we get 3 to 9? Multiply this by 3. We got to do the same to the top to keep it balanced, right? We always have to keep it balanced. Always have, whatever we do to the numerator, we got to do the same to the denominator. Otherwise, we're changing the fraction. 3 times 2 gives us 6 on top, 9 on the bottom. What's bigger between 6/9 and 5/9? Now we got the same denominator. Just look at the larger numerator, and 6/9 wins. Let's go to the next one. We got -5 1/3, -5 3/10. Okay, we can do one of two things. We can look at the decimal equivalents, or we can get common denominators. Let's go common denominators. I think that's a little easier. And also you got to remember these are both negative. So in fact, the one that appears larger, if it were positive, is going to be the smaller one. It's going to be farther to the left of 0, which indicates how small it is. So the common denominator between 3 and 10 is going to be 30. So we've got the -5s are essentially the same. We don't care about those. We just got to look which one's bigger or smaller in this case because they're negative, 1/3 or 3/10. 1/3, we multiply the top and the bottom by 10. Oops, not a lot of room here. So we get 10 over 30, negative. What about the 3/10? We multiply the top and bottom by 9, right, to get this guy, oops, sorry, not by 9, by 3, right, to get this guy to 30 on the bottom. This becomes 9 over 10, negative. Now, if they were both positive, 10/30ths would be larger than, oops, I wrote 10 on the bottom there, sorry. Should be 30. 10/30ths should be larger than 9/30ths, but we're talking about negatives, so it's the reverse. The larger number, negative, that larger absolute value, negative, is actually smaller. So this guy is smaller, and here is your answer. The negative 5 3/10 is greater, closer to 0. Finally, let's do this order from least to greatest. Again, these are all negatives. The best way to think about negatives is the closer we are to 0. The closer we are to 0, the larger the number is. Now, I can tell you right off the bat, we have, I think this is missing a bar here, we have -1 1/10, -1 1/8. The cool thing about these two guys right here is that they have the same numerators but different denominators. When this is the case, whatever has the smaller numerator, and the reason why I say this probably has to have a bar is because otherwise -1.1 and -1 1/10 are equal. So it's kind of, you'd have to put them at the same spot on the number line. Maybe I'm wrong, but just keep that in mind. -1.1 equals -1 1/10. But anyways, let's look at these two first. So we've got the same numerator right here, but different denominators. In this case, the one with the smaller denominator is actually a larger fraction, but the negative, so because this would be a larger positive number, it's going to be the smallest negative number. Let's do -1 1/8. So least to greatest, that's going to be the first one. Then what's next between -1.1 repeating and -1 1/10? Well, since I've already told you that this right here is the same as -1.1, right? 1/10 is just 0.1. We know that since this is a repeating one, the absolute value, this would be as a positive, a larger number. Therefore, since it's negative, it's got to be smaller. So we go -1.1 repeating next. Now, again, you could convert 1/10 to a decimal if you wanted to by dividing 1 by 10. Move this over, right? Because 10 doesn't go into 1. How many times does 10 go into 1.0? Just goes in 1 time. We got that decimal up top. This is going to have a remainder of 0. So 1/10 right there goes to 1.1, or 0.1, excuse me. So then the last one, the greatest one, is 1 1/10. There is your order, and done.